Your production CSS file just hit 14.2 megabytes. The browser tab crashed on mobile, and new components show raw HTML. One config mistake broke everything. Tailwind CSS v4, release 2024, replaces the content array with import tailwinds, directive, and automatic content detection. The article's Tailwind config TS content configuration applies only to Tailwind v3. If using Tailwind v4, the config file is no longer needed. Tailwind scans your project automatically. Check your Tailwind version with npx tailwinds help. The article mentions mixing CSS modules with Tailwind, but doesn't show how to use Tailwind's apply directive inside a CSS module. This snippet demonstrates using apply in a module CSS file to compose Tailwind utilities into custom classes, keeping the component markup clean. CSS module class names are hashed by default in production, which can make debugging harder. To preserve readable class names in production for debugging, set CSS Modules generate scope name in Next.js to a custom pattern like nameLocalHash base 64.5. However, be aware that this increases CSS file size slightly and exposes internal component names. Let's break down styling in Next.js 16, Tailwind CSS, CSS modules, and global styles, how it works, and the exact mistake behind that failure. Tailwind's content array defines which files the compiler scans for class names. If you miss a directory, those classes are purged. If you scan too broadly, like including node modules, Tailwind generates every possible class combination, ballooning your CSS file. The correct content config lists every directory that contains Tailwind class usage. Standard setup includes app, components, lib, and any additional source directories. Each path is a glob pattern matching the files in that directory. The wrong content config uses a glob like /**/*TS, TSX, which matches files in node modules, Next, and every other directory. Tailwind then scans millions of files and generates every possible class combination, resulting in a 14 MB CSS file. For dynamically constructed class names that Tailwind can't statically analyze, use the Safelist option. You can list exact classes or use patterns to include all variants. Here's how to add a Safelist. You can include exact classes or patterns. This ensures that dynamic class combinations are always generated, even if they aren't found in your source files. After the 14 MB incident, the team added a CI check that measures the CSS output size after every build. If the CSS file exceeds 500 KB, the build fails. This catches content config regressions before they reach production. This simple bash script checks the CSS file size. Add it to your CI pipeline to automatically detect when the CSS file balloons due to a misconfigured content array. CSS modules are the most performant styling approach for Next.js server components. They're co-located with components, auto-scoped to prevent collisions, and have zero runtime cost since CSS is extracted during build. Here's a CSS module example. The styles are imported as an object, and class names are accessed via properties like styles container. The build process generates unique class names to prevent collisions. Global CSS files can only be imported in root layouts. Use them for Tailwind directives, CSS resets, font faces, and custom properties. All component-level styles should use CSS modules. Here's the correct way to use global CSS. Import it only in the root layout. This file contains Tailwind directives and site-wide resets. CSS-in-JS libraries like styled components require client-side JavaScript to inject styles. This adds 1215 KB to the bundle and causes a flash of unstyled content on first paint. They cannot be used in server components. If you must use CSS-in-JS, wrap the component in useClient to make it a client component. This allows styled components to work, but it still has runtime cost and FOUT. Next.js uses PostCSS to transform CSS. Tailwind is a PostCSS plugin. The standard pipeline runs PostCSS import first, then Tailwindcss, then autoprefixer. Plugin order is critical. Here's the default PostCSS config for Next. JS with Tailwind. It includes PostCSS import to resolve at import, Tailwinds to generate utility classes, and autoprefixer for vendor prefixes. When multiple Tailwind classes conflict, like TextSM and TextLG, twMerge intelligently resolves the conflict by keeping the last class. This is essential for components that accept className props. Here's how to use twMerge. It merges base classes with consumer-provided classes, resolving any conflicts predictably. Tailwind scans source files for complete class name strings. Template literals like text $color -500 cannot be analyzed because the variable value is unknown at build time. Use object maps with complete class strings instead. Instead of template literals, use an object map that contains complete class name strings. This way, Tailwind can statically analyze all possible classes and generate them. For theming, define your colors as CSS custom properties in root and dark selectors. Then map them to Tailwind color names in the config. Components use semantic class names like bgPrimary, and theming becomes a data change. Here's how to set up theming. Define CSS variables as RGB values, then reference them in the Tailwind config using RGB with alpha support. This preserves Tailwind's opacity modifiers. Component libraries like Shadkin/UI and DaisyUI integrate with Tailwind. Shadkin/UI copies components into your project for full ownership, while DaisyUI is a plugin that adds component classes. Ensure your content config includes the library's files. Here's a Shadkin/UI button component. It uses class variance authority for variant management and CN, which uses twMerge for class merging. The component is fully editable. A well-configured Tailwind build produces a CSS file of 5150 KB. If your CSS file exceeds 500 KB, it's almost always a content config issue. Audit your content paths and ensure node modules isn't included. This script checks the CSS file size in CI. Add it to your pipeline to catch bloated CSS files early. This is the same issue we highlighted at the start. Here's exactly why the 14 MB CSS file happened. The team used content, TSX, which scan node modules. Tailwind found millions of potential class combinations and generated all of them, resulting in a 14 MB CSS file. The content array used /*// which scan node modules, causing Tailwind to generate a 14.2 MB CSS file. Changing to exact directories reduced CSS size to 80 KB. The fix was to replace the overbroad glob with exact directories /app /*// TSX /component /*// TSX, etc. They also added a CI check that measures CSS size and fails if it exceeds 500 KB. The CSS file dropped from 14 MB to 80 KB. Never use /*/ as your content glob. It matches files in node modules, next, and every other directory, causing Tailwind to generate a massive CSS file. Template literal class names are not statically analyzed by Tailwind. In production builds with aggressive purging, these classes are stripped, causing missing styles. This is the exact line that caused the 14 MB CSS file. Never use /*/ as your content glob. Always specify exact directories. Importing a global CSS file in a component throws a build error in the app router. Global CSS can only be imported in root layouts. Use CSS modules for component-level styles. CSS-in-JS cannot be used in server components because it relies on React context, which is client-only. Always use client or switch to Tailwind CSS modules. If autoprefixer runs before Tailwinds, it has nothing to prefix because Tailwind hasn't generated classes yet. Always run Tailwinds before autoprefixer. Without twMerge, conflicting classes like px4 and px2 both appear in the class name string, leading to unpredictable results. Always use twMerge when accepting class name props. Using hex values in CSS variables breaks Tailwind's opacity system. Always use space-separated RGB values so you can use the /alpha value syntax. To debug CSS size issues, first check your content array. Then measure the CSS file size after build. Use the CI script to automatically catch regressions. Also audit for template literal class names that might be missing. Let's run through some common interview questions. What does Tailwind's content config do? It tells Tailwind which files to scan for class names to generate CSS. Why can't Tailwind analyze template literal classes? Static analysis requires complete class name strings. Variables are unknown at build time. How do you resolve conflicting Tailwind classes? Use twMerge, twMerge, to keep the last conflicting class. And a few frequently asked questions. Why is my CSS file so large? Likely an overbroad content glob scanning node modules. Can I use CSS modules in server components? Yes, CSS modules work in both server and client components. How do I add custom colors to Tailwind? Define CSS variables and map them in Tailwind. Config TS extend colors. Let's recap the key takeaways. Use exact directories in content array. Never use /**/ glob. Add Safelist for dynamic classes. CI check CSS size to catch regressions. Ready to go deeper? Up next, image and font optimization in Next.js 16, then loading UI, streaming, and suspense boundaries in Next.js 16, then error handling in Next.js 16, error JS not found, JS and global errors and metadata and SEO in Next.js 16, from basics to dynamic OG images. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.